Hi, I'm so sorry about that. The video just stopped. I just went for a second to check something and then the tablet turned off and then the video went off. So I guess we can continue from question 17. So then, question 17, what is the relationship of the following pair of compounds? So then, I did say for some time. So if we look at the two compounds, I counted the number of carbons and then I did count the number of hydrogens. And if you see that two of them, they have the same number of carbons, but they have different numbers of hydrogens. Therefore, to be able to be isomers, we need them to have at least the same number of carbons and hydrogens. Therefore, a right answer would be D, that they wouldn't have any relationship whatsoever. So then question 18, which of the alkenes is the most stable? So then first, stability, it will go on monosubstitution, disubstitution, monosubstitution, trisubstitution. And you can see that this one is mono. You can see that this one's disub. And then that this one's disub. And then you'll be like, oh, what else can we do? So then in here we can instantly eliminate it because disub is more stable than monosub. But then afterwards it goes to cis and trans. So we know that trans, it has lower energy, therefore it's more stable. So that's why B will be a right answer. It's actually surprising on how, at least it took me a while when I was taking the test. It took me a while to figure that out. It was one of those questions that you skip and then you come back afterwards. So then question 19. In the dehydrohalogenation of 2-bromobutane, which proceeds by E2 mechanism, which conformation below leads directly to the formation of cis-2-butene? Okay, so one thing that you have to know, so then your bromine and the hydrogen that you're removing, they have to be on, they need a 180 degree, if I'm able to write it down. They need a 180 degree relationship. So then we can look at 1, 2, and 3. So then our bromine is gonna be 100% a living group. So we need to see if we're able to find a hydrogen that has a 180 relationship with it. So then in here we do. In here we have a hydrogen next to it, but that will be 60 degrees. This one will be 120. But this one doesn't really have a hydrogen on the opposite side. So technically, number 2 wouldn't be an answer. And then in here we do have an opposite hydrogen. So after we take that into consideration, it's going to be mainly about whether it's cis or trans. Because if you see, technically they're connected to the same things, but they're just organized differently. So you can technically see that they're both gonna have a cis and trans relationship. So how do I know which one's cis and which one's trans? So then when I remove these two, so technically when I remove these two, I'm gonna technically create a double bond. which is gonna give rise to a product like this. And again, when I remove these two, I'm gonna have a double bond. So that is another way to look at it. When you do Newman, you remove that bromine, that halide, and that hydrogen that you're removing. You just draw a double bond, and you draw them exactly like they are, and you're gonna be able to see, to have like a visual representation of that double bond. And you can see that we did get a cis or trans relationship. So for example, this one and this one, it will be cis because they're pointing up the same way. Also because, remember, we had priority groups. Carbon has higher priority than a hydrogen, and again, a carbon has a higher priority than a hydrogen. So therefore, they're both pointing up, so therefore cis. So a carbon has a higher priority than a hydrogen, and again, on the same side, a carbon has a higher priority than a hydrogen, but they're pointing on different ways. That was trans. And we previously said that we prefer trans better than cis. So then trans is gonna be technically like our major product. So then our answer will be C, since it gives rise to that trans alkene. So let's see, question 20. Which of the following stereoisomers give the exclusive E2 product shown? So the good thing is that they're showing us that it's an E2 reaction, so then we know that that one's gonna be, let's see, we have this OCH2, CH3. And then I did say that that one's product. And then I have a C3H and a wedge. And then I have this one on a dash. Okay, so then let's see. So they want us to find what stereoisomer could give us the product that we're given. So then one thing that we know is that we create a double bond between our alpha and our beta, right, on E2 reactions. So then therefore we are gonna keep this the same. That's why I drew it like that. And we're gonna keep this one the same. So then the good thing is that we have a cyclohexane. So then the good thing about a cyclohexane is that our leaving group, it needs to be in a wedge. It always needs to be in a wedge. So then this one needs to be in a wedge. because in here we're gonna have a hydrogen on a wedge and this one on a dash. And the thing about cyclohexanes is that when we're doing like E2, we need to have a wedge and dash relationship. So this one needs to be on a wedge, and our leaving hydrogen that is on our beta carbon, it needs to be on a dash. If not, it's not gonna be able to go through E2. So then if we look at our options, on A, we can see that our CH3, like compared to our product, our CH3, it got converted to a wedge. And this one, they're not really interacting at all with the reaction, so they should be kept the same. So this one's not an option. Neither is this one an option. So then the battle will be between C and D. And the thing about it is that it's mainly about our leaving group. So then you have to remember that our leaving group, it always needs to be on a wedge. In this case of C, it's on a dash, so it wouldn't be able to give the right answer. So our right answer will be D. Okay, question 21. So which of the following statements accurately describes stabilization effects of solvents? So then this one, I kind of like got to it with this knowledge. So we previously mentioned that that product solvents, we can do it with E2, SN1, and E1, right? We normally know that E2s, they're negatives, right? And then SN1s and E1s, they most of the time they give rise to a O, or they have like carbocation most like for a prolonged time that I need to. While SN2s, they're normally just negatives, right? So then these are called cations, and then this one's called anions. SN2s deal with a product. So then technically, you can see product, it deals with both anion and cations, while aprotic, it deals with anions. So then technically, product solvents, they stabilize both cations and anions. And that's how I got to my answer. And you'll be like, why a product solvent stabilize anions only? That one would be just because the thing is that you can get that is like 99% true, like that a product solvents, they stabilize anions, but they can also stabilize cations. Because the thing is that in a reaction, like you can get this, you can get like, for example, this reactant, and then you can get this solvent. But then sometimes, the reactant's gonna have higher priority than the solvent, so then the reaction can still go. It would just be slower. Well, on product solvents, it will be more like 100% true that the product solvent, it will stabilize both the cations and ions because it deals with a bigger range of reactions. So then question 22. So draw the transition state for the following reaction. Okay, so this one's fun. So then transition states, they normally include the leaving group, they include the group that's gonna come in as well. So for example, if we were to look at this reaction, we can see that our chlorine leaves, and then our SH it attacks it. So let's see, I have this carbon in here. And then I have my CC, so I have 1, 2, CH3, CH2. Then this one has a hydrogen. And then I'm gonna have my nucleophile on one side, and then I have my leaving group on another side. So then my leaving group, I'm gonna have it in this way, while my nucleophile is gonna go this way. And we cannot forget about our sign of transition states. So then we need all of these components. So this one will be like my right answer, which you can see that it's gonna be 2 overall. But then you need the transition state. You need your you need what's coming in, your nucleophile, you need what's coming out. You need to show the stereochemistry, and you need to show what's connected, like what's the rest of the substrate. So those are the main requirements for a transition state. At least for a transition state for that specific reaction in that case, which in this case it will be an SN2. So question 23, what substitution reaction mechanism is most likely following the conversion? So then you can see that in here, this whole thing is conserved the same. The only thing that changes mean is this one. So then that points up that we have a substitution. And we originally have it on a wedge, now we have it on a dash, so we have inversion of configuration. And the only reaction that's able to do inversion of configuration is SN2. So our right answer would be B. So question 24, which of the following is the major product of the following elimination? So then this is technically about knowing a little bit on how to do the mechanism for this. So then the thing is that in here we don't have any peroxides, right? Or ROR. So then our product, it will be Markovnikov, meaning that the bromine, it will go on the most substituted, or hydrogen, it will go on the least substituted side. Keeping that in mind, our double bond is gonna take that hydrogen, and we're gonna break that bond and put it on the bromine. And like we said, we're gonna put our hydrogen on the least substituted, or the side that has more hydrogens, meaning our side with the most hydrogens will be up here, right? So then meaning that we're gonna put that positive charge in here because we don't have anything connected to it, and also because afterwards that bromine is gonna be able to attack that positive carbon and give rise to this product. So then which cation will be first formed in the following reaction? So then the first one that's gonna be able to be formed is gonna be B. Just because as we saw, we put our hydrogen on the least substituted, meaning that we put it up here on this area. Therefore we needed to put a positive charge on this side, and it was asking for the first what carbocation will be first formed. Oops, I guess I wrote it again. So question 26. In the first step of the mechanism for addition of HCl to the alkene, which species acts as a base? So then that one it can take you a little while, but sadly we do have to remember our definitions. So then if we consider the definition of Bronsted-Lowry base, a Bronsted-Lowry base is going to be the one that's going to be able to accept the proton. A proton is a hydrogen. So then you can see that our alkene is the one accepted a hydrogen. So then the species that would act as a base is our alkene technically, because it's taking a hydrogen from that HCl. And technically, just for elimination purposes, RCl is gonna accept an electron pair, so therefore it's gonna be an acid. So then HCl is not. H plus, not really. You can't. It's not really gonna accept another proton, and you're neither able to like technically done. You're able to done it, but it's not technically gonna be able to accept another product from it. And then chlorine eventually is gonna act as a nucleophile, so therefore wouldn't be able to do so, giving rise to our alkene being our only answer as well. So then question 27. So consider the following formation. Consider the formation for each of the following carbocations. Which transition state will be the highest? So then we have to think about it this way. So then carbocations, we said that stability goes from benzene to resonance to primary to secondary to tertiary. And then we have a benzene that it's like this. And technically we can just for purposes of you being able to see on why this one's more stable, because we have more resonance eventually on benzene. Okay, so consider the formation of the following carbocations and which transition state will be the highest. So then you're gonna have more energy when you're least stable. So then if we look at our chart, the least stable is gonna be a metal carbocation. So that's why it will be your right answer, because transition states are mainly about energy. You're gonna produce more energy when you're least stable. So therefore metal will be the transition state that will be the highest. So question 28. Give the expected major product of the following reaction. So then this one is an acid catalyzed hydration. This overall is an acid catalyzed hydration. It means that we're gonna be breaking that double bond and we're gonna add a hydrogen on one side and an OH on the other side. And the OH is gonna be in the more substituted and the hydrogen on the least substituted. And if we're chiral, or if we create a chiral center, we have our product and plus an enantiomer product. Luckily, since we don't have to deal with any chiral centers, so we don't have to worry about that. We just have to worry about putting the OH on the more substituted and the hydrogen on the least substituted. So then thinking about that, this one will be a right answer. Meaning 4. Because we're technically just we're breaking this bond. Because I want you to be able to see it. So we're kind of breaking this bond, and we're gonna add a hydrogen on the least substituted and then OH on the more substituted. And that's why we get that answer right there. We can also look at the mechanism for it. So in the mechanism is technically that we're gonna take a hydrogen from water. So then let's see, I can draw it as well. So then we have an H plus OH. So then I can do it like this, OH. So then my hydrogen again, it will go on the least substituted. So then here I have already 1, 2. So I would just add one more hydrogen to that one. And since I broke that double bond, the other side will get a positive charge. Afterwards, I'm gonna bring an OH2. Oops. So I'm gonna have a positive charge. So then I can just bring my water again. And I can remove that extra. And I will still get the same part. So that there's different ways technically. Like you can just memorize the fact that it will be like the addition of a hydrogen and an OH across a double bond, meaning that OH will be in the more substituted and the hydrogen on the least substituted. You can learn the mechanism. You can see we have a hydrogen plus. In here I have an OH3 technically, because I will get that from an H2OH plus. And then afterwards I have a water, then that water again, it will remove that extra hydrogen that oxygen has, and then I will get the rest of this product. So then this will be like the whole mechanism for this. So there's different ways of knowing how to get eventually to the answer. Question 29. So why does this reaction selectively form this product? I mean, it technically doesn't really explain it. It does. So then the thing is that HBr, it's gonna be a Markovnikov, meaning that we're gonna be adding our Br to the more substituted, and then our hydrogen to the least. So then you'll be like, okay, so then on this side, if I were to put my, I'm gonna add a hydrogen eventually, and then one side is gonna get the hydrogen and that other side is gonna get a positive charge, right? So then if this charge was the one, if this size was the one of getting that positive charge, I'm gonna be able to do resonance, right? Well, on this other side, if this one was gonna get that positive, it wouldn't be able to do resonance because it would be too far away. So then therefore what I would do is technically I would end up breaking this bond. And then I would end up putting my hydrogen in here. And then I will get a positive charge in it, which later will be attacked by a bromine. I'll be like, where did you get that bromine? Well, that double bond, it got a hydrogen from here. So then the hydrogen was placed in this area. Therefore, on the other side of the alkene, I will put a positive charge. And that positive charge was gonna be eventually attacked by that bromine that left. So then technically our answer will be C, because it was mainly about resonance on why that hydrogen was placed on one side of that alkene versus the other side. So then question 30, what is the major product of the following reaction? So then you can either know how to do the mechanism, or you already know that this one's gonna be a Markovnikov, meaning that the bromine on more substituted, and then the hydrogen on the least substituted. So then my hydrogen will go on the least substituted, meaning I will place it in this side, while my bromine it will go on the most substituted. But we have a negative and it's gonna attack that positive. And you know, a nicer way of drawing this, it will be this, like this. And then afterwards, it's about knowing how to do IUPAC rules. So then technically, if I was to name this one, we have to remember that IUPAC, we first identify our longest chain. 1, 2, 3. So then my longest chain is gonna be this one, which is gonna be 3. So then therefore it's gonna be a propane, methyl ethyl propane. Yeah, propane. 1, 2, 3. So it doesn't matter really side, because it will end up being, our substituent would end up on number 2. So then we have to circle substituents. Oops. So then this one is gonna be a metal. Substituents are what hangs from the parent chain. And then this one's gonna be a bromo. So then, like I said, we can count from either side. I'm gonna count from this side. 1, 2, 3. So then we have to alphabetize our substituents. So then bromo, it will be as a B, and then metal will be as an M. So then that means that the bromo one will go first. So then I have 2 bromo. Then my other substituent will be, or my substituent that's left is metal. It's position carbon 2, so I have 2 metal. And then I have my parent chain, which will be propane. So this should be my answer: 2 bromo, 2 methyl propane. And there we go. And that should be everything for exam 3. So thank you for taking your time for reviewing with me for this exam, and I really hope that it goes well, and I think you guys got it. If you guys were able to get through the whole videos, or you were able to do all the chiefs, I think you should be pretty good by now. And if you have any questions before the exam, because I think you still have like a couple of days before it, not a couple, but possibly, like, I think it's either this week or next week. So I think you have plenty of time to study. So if you have any questions, you can email me, and I wish you guys good luck, and thank you very much.